morning and thank you to the organizers to give me the opportunity to present here. So my work is basically I will present on role of aromatics in the fuels, that what are the roles of aromatics. I have seen the presentation, we have some long-term plans like hydrogen, methanol, but to go for the cleaner fuel, we have to have some short-term plans also to go towards the clean energy. So starting from some of the colleagues from France, they have they have asked me that where is this? Are you from Bangladesh? So this is basically here. So we have a chicken neck from here, and this part is connected, and this is also Indian part. So I am basically from this location. We have NIT at that place, and we have more than 10 different BTech branches, MTech, and more than 4,000 students. So now come to this particular slide. I have prepared this after the suggestion from Avinash, so that it is not the basically engine that is responsible for the emission. Basically, this is the fuel that is responsible for the emission. You might have seen this type of pictures, millions of pictures on internet, that we have emissions from the cars or automobiles like this. If you see, this is basically a contradictory picture. We do not have CO2 as a fuel. Okay, they have mentioned that you have hydrogen and have green, but we do not have. We have a fossil fuel. So this is not the correct. We have to be very careful about this. So basically, this is a fuel that we have combustion, and then we have different emission. So it is the fuel that is responsible for emission, not the engines. So we have to go for the approach like basically clean fuel and advanced engine technologies. We have to go for the modification in engine technologies. Even we have to go for EGR type, basically after treatment of the exhaust. Now come to the diesel composition. Okay, so we have basically diesel. That diesel has different basically chemical, like alkanes, we have isoalkanes, we also have cycloalkanes, and here we have aromatics. So aromatics, why these aromatics are important to study? If you see this particular slide, in Australia we even have a bill with low aromatic fuel bill. Okay, we also have various reports on this, that why we have to basically understand the importance of aromatics in the fuel. And but we have two major questions. That low means how much it should be. It is 5%, 1%, 2%. And second one, basically type. We have different aromatics, not a single aromatic. We have a chain of aromatics. So we have to think that which one is good or which one is bad, or can we remove all the aromatics from the fuel. So this question we have studied. Here is the motivation came from. We got one UCARI project that is a part of this. Actually, NASA has done one test for the jet fuel without aromatics, and they found, after basically running the engine, a stationary engine for 24 hours, they found that leakage due to the seal swelling. Sir also showed some of the result of seal swelling, and that was a reaction of elastomer and fuel when we have low aromatics. That is a different study. I will not go into this phenomena, but that is the reason just for the seal swelling and leakage they found. Then we come to the again this question. This has higher content in fossil fuels, up to 30%. In diesel we have 25-27%. Aromatics are the main contributors for the PM and soot emissions, but not all the aromatics contribute to the same level of emissions. Every aromatic has their own basically contribution for the emissions. Aromatic content are essential for fuel compatibility. If these are essential for fuel compatibility and they are also reason for the high level of PM emission, so how to go for this? Then we have to think to select appropriate content and species of aromatic for low emission formulated fuel. So we need a fuel that has low aromatic, so that we will have low emission, but that should have some aromatic so that we will not face any issue of the seal compatibility. now the methodology started with, we have taken basically simple alkanes, hierarchy alkanes, and took some aromatics, 13 different type of aromatics, evaluate their properties, and then we have performed some performance emission analysis, and then we have selected one optimal aromatic based on this. So these are the different aromatics that we have studied, starting from monocyclic and then polycyclic. If you see here, we have done basically compositional analysis of diesel. In diesel, we have monocyclic aromatics nearly 20.5%, polycyclic aromatics nearly 3.1%. So we have the diesel we have tested that has nearly 23.6% of aromatics. Now we have done the study. If you see different aromatics, we have 13 different aromatics. If you see here, even though we have a similar content of the aromatics, but we have a difference from basically 370 here to nearly 320 for ethyl benzene. Okay, that was happened due to the physiochemical properties of ethyl benzene that has low boiling point, also have basically single chain of carbon-carbon. And similarly, we have checked the NOx emission. We had some issues, but we have optimized this. I'll show you one more graph that has a correlation, that which one is the better. Then we have also analyzed the sound level also, and then basically we have seen that this change is happening because of basically H/C ratio, different H/C ratios of the aromatics. Second study we have done for basically this spray and unregulated emissions. Due to the that has basically lower better properties. So for ethyl benzene we have better spray pattern. So we have done this, one of my colleagues, the spray analysis for these fuels. And then we talk about PM and aldehyde. We have done basically the particulate matter and aldehyde emissions for some of the blends, like for some of the aromatics like ethyl benzene, indene, petroleum, alpha methyl styrene. These are monocyclic, these are basically polycyclic. If you see here, so we have basically this PM emissions. We found results again with low aromatics, we had lower PM emission as we increase. But we found one very interesting result here. If you see formaldehyde, we had basically more formaldehyde even though we have lower PM emission. So not only the PM emission is the criteria to select any fuel, okay, but these are not the regulated ones, so we are not focusing on this, but actually these formaldehyde and aldehyde, these are basically two major pollutants that are under 13 pollutants which are like mainly more harmful for the human health. Then if you see here PM NOx correlation, we have basically along with this PM we have lower HC and CO emission due to better physiochemical properties. Still we are working on this basically chemical kinetics. I was discussing with Sneha that we have to perform some chemical kinetics to understand that why this is happening. Okay, but if you see here for the ethyl benzene, so this is I think the best option, because for this we have basically lower PM and lower NOx emissions comparatively. So this basically fits well. So we are also performing some seal compatibility test nowadays in University of Alabama to see that how that particular ethyl benzene impacts the seal swelling. So this is the collaborative work on the same aromatics. So we have tested this in distributed combustor. So Dr. Saurabh Sharma have done this work, and we found the similar terrain. Then we have done this work in University of Sheffield with Rolls-Royce combustor rig, and we have found that here also we have basically better results for the monocyclic aromatics. And the main reason is basically the carbon chain, and these are the main reasons basically, and physiochemical properties. Then we have conclusions starting from this, that structure of aromatics highly influence the engine emission. And then if we have a single ring monocyclic like ethyl benzene, methyl styrene, they have basically contribute to less PM emission compared to the polycyclic. And then ethyl benzene and toluene have shown better results. And PM emission should not be the only criteria, because we have more basically non-regulated emissions compared to this, and unregulated emissions are also equally important to study this. So yeah, these are our publications from this work, and we have shared this data with HPCL, and they are also looking for this thing, and they have prepared one catalyst to remove the aromatics from this organic solvent. So yeah, thank you. This is my team and knowledge.
Thank you very much. We have a lot of time. So we can have some questions. Is there a question there if you have the microphone?
Paramvir, so polycyclic aromatics produces more PM particles as expected, right? Whatever aldehydes, the polymetric aromatics are responsible for large amount of aldehydes.
Pardon?
Aldehydes. So polycyclic aromatics produces a large concentration of formaldehydes, right? Compared to single. Okay. That is also expected. And what about NOx?
NOx is basically higher for this. When we have
Higher for polycyclic.
higher for basically monocyclic, because the temperature is higher in this case and PMs are low. But if we can optimize this then basically number, then we can go for the optimized result, that is with ethyl benzene. I have shown in NOx and PM relation, the correlation graph.
So you also presented some results on performance or only emissions? Maybe I missed.
No, only on emissions.
Any idea like
Yeah, we have
efficiency
done.
was increasing or remaining same?
Actually, this is like in range with the diesel for the ethyl benzene. We have done VSFC and BT both.
Question? We found
Paramvir, this whole idea of putting polycyclic aromatic hydrocarbons in the fuel has been attracting a lot of attention from the environmentalists. There is a lot of pressure because what happens is when you have polycyclic aromatic hydrocarbons in the fuel, in the reactor-like conditions, they get further converted to nitro pHs and things like that, which are very toxic.
Yes.
And it creates a lot of problem, and that's what causes toxicity of the particulates, and that's what is responsible for diesel engines or diesel being declared as carcinogenic from producing carcinogens. And I think the global effort has been on reducing the pHs, polycyclic compounds from the fuel.
Yes.
So any comments as to, you recommend that you should be adding certain optimized conditions of composition of pH in the fuel. So these are two contradictory things actually. So any comment on that?
Actually, sir, we have studied with both like polycyclic and monocyclic, and we have found basically that monocyclic with ethyl benzene we have better results, even though we have little bit higher NOx. But if we can remove pH, because as you mentioned that these are the carcinogen, basically these are main pollutants that are harmful for the human health. So we have proposed to remove these polycyclic hydrocarbons from the diesel, and just because if we remove this, we have a problem of seal compatibility. But we can manage this with the ethyl benzene, that is monocyclic, that is not that much harmful.
My contention was slightly different. You have done regulated emissions study, right? You have not looked at what is coming out of the tailpipe in the form of DHAs or nitro PHs,
We
liquid form and solid form. Have you looked at it?
Yeah, sir, we have done one basically study on unregulated emissions.
What techniques did you use, up to what levels?
We have done through, sir, we have not done that much. We have done for formaldehyde and aldehyde.
Formaldehyde and aldehyde is nothing. It doesn't you need to do.
Not for this.
So
We will
even let me
will
tell
do
you
this.
that the aromatics, the exhaust, even in nanograms are toxic,
Okay.
and it is not allowed. So before you really recommend or make a serious research effort
Okay.
on this direction, my suggestion will be
Yeah, we'll
look
do
at
it.
the toxicity.
We'll do it.
And unless and until you have the capability to test what kind of pH is coming, what could be the possible implications of the human cell lines,
Yeah.
or for example on our body,
Yes.
or our lungs.
Yes.
Until equipment because
Okay.
you are only doing a very limited study
Yeah.
to regulated emissions, maybe formaldehyde, acetaldehyde.
Mm-hmm.
But maybe it may be good for the rubber, but it may not be good for human rubber.
Yeah.
It will destroy.
Yeah, we'll do.
So one has to be little careful on that.
Thank you, sir. Thank you for your suggestion.
Thank you for this discussion. Maybe one more question. We have time, but we also have a trip after this, so if we end in some minutes, it's always better. You have a question over there?
Last question.
You have the microphone, but no question.
So it is not really a question actually, because I have some experience in pH analysis and its toxicity related issues.
Okay.
So I mean, overall the PM emission itself is like actually very less in exhaust emission, total exhaust emission. But the pH concentration in the total PM is even less, only 1 to 2%. But the toxicity level of the PAH, polyaromatic polycyclic aromatic hydrocarbon, is too high actually compared to the whole particulates. So that I would like to, I'm actually in agreement with Professor Agarwal. Like this PAH actually is one of the major component responsible for the higher toxicity level.
Yeah.
So that can be actually good.
Okay. Thank you, sir. Thank you for the nice suggestion.
Use ECMS.
Yeah. Thank you, sir.
Not only
So
benzene,
what happens is that it is not just benzene. Yeah, multiple of these benzene rings fuse, and then nitrogen also goes in addition. And then it causes cancer. We have done some experiments on human cell lines exposed to different particles, and cancer multiplies.
A good research is the one that arises more questions, so thank you very much for your presentation.
Thank you, sir. Thank you.
Continue with the discussion.
Long live India and France friendship.